In the entire known universe, we know of only one tree of life. Is it really the only one, or is it merely a part of a vast cosmic forest? Imagine a museum that contains every form of life, from all corners of the universe. What strange or frightening beings might we find under its roof? To discover extraterrestrial life, we need to know what we are looking for and where. So where do we begin? How can we limit the almost infinite stream of possible variations of alien life? So far, it is only limited by our imagination. We know for certain that life always adheres to certain rules. Life on other planets may seem very strange, almost phantasmagorical, but it must be constrained by the same laws of physics and chemistry that limit us. Moreover, the characteristics of each habitat enhance these constraints and, as a result, reduce the variations of possible life forms. Despite all the natural barriers, these variations are difficult to conceive. Just imagine the scale. Trillions of planets, each with its own unique composition of chemical elements, its own tectonics, its own star, and a multitude of other conditions directly influencing evolution. Our museum will be divided into two sections. Life as we know it, where creatures similar to our biochemistry will be displayed, and life unknown to us. The creation of a life form is a challenge to our perceptions of modern science. Section number 1. Life as we know it. What do you think unites all known life on our planet and possibly beyond? It is carbon. Carbon is ubiquitous. It is one of the most common elements in the universe, and most importantly, it is an excellent building material for large, stable molecular compounds. This element has a remarkable and very rare ability to form stable and strong bonds with other elements, creating entire chains. These parameters make carbon the center of the molecular mechanism of life. Through the study of meteorites, we have found that carbon compounds can be found far beyond Earth. Scientists have discovered over 1 million possible alternatives to DNA, but all of them are based on carbon. If we ever manage to detect extraterrestrial carbon-based life forms, we will be shocked by how similar we are at the most basic, fundamental level. They could actually be our brethren. But will they resemble us in any way? If these beings are from Earth-like planets, we may have even more in common than just biochemistry. Imagine animals and plants that are very similar to those we can see on our home planet. On Earth, living beings have a certain standard set of ways to interact with the surrounding world. Vision, echolocation, flight, and many others. All of them have undergone evolutionary changes many times. This is called convergent evolution, the process by which similarities arise between organisms of different taxonomic groups living in similar conditions. There is a possibility that such phenomena could also occur on other Earth-like planets. For example, depending on the conditions, an animal may develop large organs of vision during the course of evolution due to existing in low-light conditions. And this rule could be a kind of universality for all life in the universe. But what about humanoid beings, or in other words, beings of humanoid type? The scientific community continues to debate this issue. But let's just imagine that even if at least 1 out of 100 trillion Earth-like planets produces a humanoid organism, then there could be thousands of similar species in the universe. However, it should be understood that in reality, it will be much easier to discover beings that occupy lower tiers in the hierarchy of living organisms. What about plants? Will they look like those on Earth? Let's start with the most striking characteristic of terrestrial plants, their colors. On Earth, plants appear green because they absorb all the other colors of the spectrum with their surfaces. However, stars can be of absolutely different colors. Alien flora will develop its own unique pigment, adapting to the star in its native star system. Plants on a planet illuminated by a hot star may be red due to their absorption of the color spectrum of such a star, which is blue. If a planet is illuminated by a dim red dwarf, then the plants on its surface could be black, adapted to absorb all possible light waves. It is believed that the most common color in the plant world of different planets could be purple. But undoubtedly, the decisive factor for life is not the properties of the star, but the characteristics of the planet itself. What will happen if we increase or decrease the cycle of day and night? What will happen if we change the shape of the orbit or the strength of gravity? Planets with elongated elliptical orbits, for example, will experience sharp changes in seasons. Most of the discovered rocky planets are considered so-called super-Earths. Their mass can be equal to 7 Earth masses. This means that the force of gravity there is an order of magnitude higher than on our home planet. How can life develop there? In water. The force of gravity will be felt much weaker in an aquatic environment. On the surface, animals will need large, strong bones and significant muscle mass. They will also require a more reliable circulatory system. Plants on such a planet will likely be low-growing. Planets with weak gravity more readily part with their atmosphere. What does this mean for life? Little atmosphere means little protection from cosmic rays. The surface of such planets may be completely lifeless. But even in these worlds, hidden oases can exist, branching systems of caves where the local flora and fauna are not affected by surface conditions. However, it is worth noting that the presence of complex life forms is, most likely, a cosmic rarity. On Earth, the process of evolution took nearly 3 billion years to create a complex plant and animal world. Simple organisms are more widespread and, most importantly, adapt much more easily to external conditions. Thus, the largest portion of Department Number 1 will be a giant exhibition of simple organisms. Finding at least them will be a major achievement for Earth science. But what if our search is complicated by the fact that we are looking not where we should? What if Mother Nature has a more developed imagination? Department Number 2. Life unknown to us. Most planets in the universe are too cold or conversely too hot to maintain water in a liquid state on their surface, and, consequently, for the biochemical processes that can support life in the form we know. Perhaps we need to look outside habitable zones? We have already talked about the fact that no element can compare to the flexibility and universality of carbon. However, it does have a close competitor, silicon. At first glance, silicon looks very much like carbon. It forms similar chains of bonds and is also quite abundant in the universe. But upon closer examination, differences can be seen. Silicon's bonds are weaker and less suitable for creating complex molecular structures. However, unlike carbon compounds, they can withstand serious extreme temperatures, which could provide life with incredible opportunities. Silicon has one unpleasant property. In the presence of oxygen, it turns into solid rock, so creatures with a silicon structure would be impossible to encounter on planets with oxygen. For example, one of Saturn's moons, Titan, with its vast lakes of liquid methane and ethane, could be a home for such beings. On such frozen planets without access to sunlight, and therefore to vegetation, creatures would likely possess the ability for chemosynthesis, which is a method of nutrition where useful substances are produced from the oxidation reaction of inorganic compounds. Surprisingly, this literally means that such creatures could feed on stones. Such life forms may have a very low metabolism, and their lifespan could reach millions of years. Is life possible on scorching planets? The silicon bonds under conditions of extremely high temperatures become more flexible and reactive. It turns out that even in such hellish conditions, life is theoretically possible. There is also the assumption that such beings may inhabit deep beneath the surface of our planet, in its magma core. Clouds of dust in outer space are the last place one would think to search for life, right? But when this dust comes into contact with plasma, something strange happens during the reaction. In experimental conditions, dust particles that get caught in such a reaction begin to self-organize and connect into spiral structures that vaguely resemble DNA. Some scientists suggest that this is an example of inorganic life forms. But the problem is that in reality, such a reaction could only be observed through computer simulation. Plasma is the most common state of matter in the universe. If there is life within its crystalline particles, it could be the most widespread in cosmic space. When massive stars are near their collapse, some become superdense neutron stars. Conditions on the surface of these stars are simply unimaginable. Gravity is hundreds of billions of times stronger than on Earth. But beneath the surface lie entire seas of hot and dense neutrons and subatomic particles. In theory, the nuclei of these particles can combine to form large macronuclei, and then even larger supernuclei. It is suggested that this incredible life is born, exists, and perishes within short intervals of time. Finally, it should not be forgotten that life can develop artificially. It can be created artificially. Free from all biological constraints, artificial life forms, machines, could be the most successful beings in the universe. They could exist in any conditions, even in the vacuum of space. Unlike natural selection, technological evolution allows for growth and adaptation much faster. As if intelligent machines, capable of reproducing themselves and colonizing the most dangerous corners of the universe, are descending upon us from the pages of science fiction novels. Agree, one can come to the conclusion that mechanical life is a possible culmination of organic life, its crown, to be precise. Thus, our journey through the fantastic museum of extraterrestrial life has come to an end. It's a pity, but at the moment, earthly flora and fauna are the only exhibits in this museum. However, we are asking the right questions, and we dream of one day making eye contact with a being that may be radically different from us in appearance, but whom we can rightfully call a brother in mind. And when that wonderful moment arrives, we will never feel lonely again while gazing at the starry sky.